Hello class, Mr. Bean here, and today's video is going to be about vectors. We talked about a little bit during the summertime, but this is more of a formal introduction to vectors. This will be the start of Unit 2, Section 2.1, Vectors. Unit 2 is going to be Dynamics and Newton's Laws, and this over here is going to be this over here is going to be notes here that you can take. Everything we talk about over here is also over here as a note taker. And plus, we'll also be using some problems from here as well. Okay, so what is a vector? So right here it says a vector is a combination of exactly two values. Magnitude, which is a number which describes size, and direction. So let's take a look at a vector. Let's take a look at this over here. Go ahead and come over here. And suppose here we have vector A. So let's go ahead and bring it over here. And this is a vector, and we'll call it vector A with a little arrow on the top. Now, if you notice here, I'm able to move the vector around. I can move it here, I can move it to the origin, or I can move it up here. The thing is that a vector is free to move in space. However, the only thing you cannot do is you cannot change the angle, and you also cannot change the size. But other than that, a vector is free to move about, like so, and we'll be using this technique a lot. So let's go ahead and kind of see what we got here about this vector. So let's take a quick look. We'll put the vector here, but also let's note here that this is a Cartesian coordinate system. Here's quadrant number 1, here's quadrant 2, quadrant 3, and quadrant 4. So whenever we have a vector, as we see right here, we always want to make sure that the angle at which we measure it from is always from the positive x-axis. From trig class, we have to, sometimes you worry about the coterminal angle and other angles and such and such. But in physics here, we'll always measure the angle here from the positive x-axis. Like here is 45 degrees. All right, so if I was to go over here, this would be 135 degrees. Over here, we're in quadrant number 2. Now, if I bring this down here, now notice the software here gives us a negative 135 degrees from the positive x-axis going down like this. So, however, if I wish to continue to use the reference frame of 100 from the positive x-axis, I will need to take 360 degrees, and I'm going to subtract 135. So therefore, the angle from here to here is 225 degrees. From here to here is 225 degrees. Now, if I bring it over here, like so, this is negative 45 degrees here. But I want to measure this angle here going all the way around. So if I do that, if I take 360 and I were to subtract 45, this would give me 315 degrees. So this angle right here is 315 degrees. All right, so that's something that we want to just be aware of. But anyways, let's take a look over here. Let's put this vector in the first quadrant. Let's put it right there at 45 degrees. Now up here, it tells us the magnitude of vector A. It's telling us how big is this arrow here. It's 7.1 units, okay? And the angle is 45 degrees. Now over here we have AX and AY. These are the X and Y components of this vector. So if I go over here and select this, you see here that we have an arrow here and a dashed line here. This is the AX component, and this is the AY, or the Y component. Likewise, I can also move it over here. This is AX, this is AY right here. Okay? So these are the components of this vector. And sometimes you can, sometimes see it better like this here. All right, so that's a vector here. And notice here, so let's go back to right here. So this is the head and this is the tail of this vector here. So the component form here tells us if I start at the origin, just like math class, I go 5 units this way, that's the X component, and I go 5 units up, and it gives me the location or the head of where the vector points to. So this will be the component form, 5 units over and going up 5 units. Okay? So that's the X and Y components. So all vectors can be broken into X and Y components. Okay? And we'll go ahead and get rid of this angle here. And let's take a quick look over here and see what we got going on here. Okay. Again, this is some things that we just talked about over here. And let's take a look at this example right here. It says a marble starts at the origin and rolls 45 meters east. Describe where it ends up in vector notation. All right, so if I were to do this here, I would make my coordinate system like this. Boy, I need to get a stylist. Okay, so it says here it starts at the origin, which is about right here, and it moves 45 meters to the east. Now, so we get our uh, orientation correct, this will be north up here. This is north here. This will be east over here. This is east here. This will be west over here. And of course, this here is south, like so. Okay. And so it rolls 45 meters east from the origin. So we're right here and it goes this direction. We draw our vector here and the marble ends up right here. Okay, and it says here, describe where it ends up in vector notation. So we could call this, maybe we'll call this here vector A, just to give it a name here, vector A. We put a little arrow on top here, give it vector notation. So we could say the magnitude of A here, we'll go right here, the magnitude, okay, the size of A, like so. The size of A is going to be 45 uh, units or 45 meters here, like so. And we'll go here. And the angle theta, the direction, is going to be 0 degrees. Go here and we'll say 0 degrees. Okay. Now, I could also set 45 meters east as well, but 0 degrees. Boy, I need to get a stylist here. Oh man, it's terrible. Okay, so over here it says a marble starts at the origin and rolls 45 meters east, then it moves 90 meters west. Describe where it ends up in vector notation. So again, here we'll go ahead and draw our XY axis here. Here's our origin. Okay, so it rolls this way, about 45 meters here. Then it goes 90 meters this direction. So it ends up about 45 degrees here, or 45 meters in this direction. So here's where the marble ends up here. And so we describe this in vector notation. So we would say the magnitude of vector A, here's the magnitude of vector A, little arrow here. The magnitude of vector A is going to be 45 meters. Remember, it's always positive. Magnitude is always going to be positive. Man, I got to see 45. Like so, there's 45. Okay, let's get rid of this here, 45. And the angle theta, okay, is going to be 180 degrees. So this is the angle like this, right there. So theta is going to be 180 degrees. And that will be the vector here. So I'm going to say here 180 degrees. All right, so that's the vector here. Okay, so let's go ahead and scroll down some more. And here it's talking about components, okay, components here. Okay, and let's take a quick look here and see. Uh, uh, you can do the reading here, but let's take a look at this example right here, number 3. Marble starts at the origin and moves 5 centimeters. Okay, moves to the right 5 centimeters. What is this new displacement in vector coordinate terms? All right, so what we have here then is vector coordinates. So we have here, there's a x component here. We call it the same vector A. Here's here, this will be the y component here. We'll go here and we'll make this here the y component. So the x component says here 5 centimeters to the right. So that means if we have our little axis here, it went 5 centimeters to the right, which is kind of like that. Boy, man. Okay, so the x component would be 5, like that, would be 5. And the y component would be 0 because it went in no direction in the y direction, no meters in the y direction. So notation form, this handout uses this here, kind of like in math class. We do the coordinates. There's 5, and here is 0, like so, okay, like that. Or I like to write with brackets. Uh, 5 is the x component, and 0 is going to be the y component, like so. Okay. Over here, suppose you move to the right of the origin by 3.5 meters, then up 5.6 meters. What is the final vector from the origin in coordinate terms? Okay. So let's draw a quick arrow here and kind of get an idea of what happened here. So it said here it went to the right 3.5 meters. So there's 1, this would be 2, here's 3, and here is 4. Okay, so it went about 3.5, which is about right here. Okay, then it went up 5.6. So here's a 1, 2, 3, 4, 5, 6 up here. Okay, so 5.6. So it went up here about 5.6 like that. Okay. And this here would be the resultant vector. Okay, this is called the resultant vector here, or the actual original vector, and this is the x component, and here's the y component. So what I would do here then is in vector notation form, the x component here is 3.5, so we'll go ahead and put in here 3.5, like so, okay, and we'll do a comma, okay, make sure that's good, and the y component is 5.6. We'll go ahead and put down here 5.6, like so. All right, and then that would be the vector from the origin in coordinate terms here. All right, let's go ahead and scroll down some more. And this is going to ask us to find a vector's components. Find a vector's components, okay? So let me make this a little bit bigger here, but we're not going to need this too much. Let's kind of slide this over here like so, and make this a little bit bigger, okay? And let's see what we got here. So it says here, resolve a vector 3 meters long at 15 degrees into its components. Okay. All right. So up here is the theory in the background over here. So we'll take the theory here and we'll apply it right here. So let's go ahead and write the original vector. So the original vector, we'll say is vector A, and go ahead and kind of write it like this here. So the magnitude of this vector given to us is going to be 3 meters, like so. So there's 3 meters, okay? And the angle theta is going to be 15 degrees, okay? So here is, right down here, 15 degrees, like so. All right, so there's the original vector. So to put it into as AX or a component, X component form, we'll go AX here, okay, is equal to, and it's going to be A right here. Here's A, and we're going to go ahead and say this is going to be the cosine of theta, like so. Okay, cosine theta. Now, if we were to do this here, A, of course, would be it's the magnitude. So the magnitude would go over here. The magnitude. So this would be 3, like here. There's 3, and we would say is the cosine of 15 degrees. I'm going to put down here 15 degrees. Okay, and let's see what that equals. So over here, I have a calculator. Now, if I use this calculator here, it's going to default, let's move over here. It defaults, when we use it, it's in radians. We must be in degrees. We'll make sure we're in degrees here. So using this here, we'll go 3, and we'll go ahead and go cosine of 15, like this, close parenthesis, and let's see what we get. We get 2.89, or we'll round it to the nearest tenth, and we'll say 2.9. So it's 2.9, like so. Okay, 2.9. And now for AY, we'll do the same thing, except the y component will involve the sine. So here's AY is going to be 3, and we'll say here sine of theta. So here's the sine of, let's say, 15 degrees. Okay, and here we go. So we'll go ahead and put in here 3. We'll go sine of 15 degrees, close parenthesis, and we get 0.77, or we'll round to 0.8. So we'll say here 0.8. All right. Now, so this is doing it old school by hand. Now, there's a couple vector calculators you can use online. And we will make use of these because I do not want to turn this into a math class per se. I want us to be able to use the vectors. So take a look at this tool here. I love this. It's called mathisfun.com, vector calculator. So let's go ahead and see what we got here. So here's the vector. Magnitude is 3. So we'll go ahead and put in here magnitude. We'll go ahead and put in 3 here. And the angle is 15, like so. 15. And notice here it breaks it into x and y components. So here's what the vector looks like, and this is 2.89, we rounded it to 2.9, and this is 0.77, and we rounded to 0.8. So this is a good tool for us to use once we have mastered or know how to do it by hand. All right, let's go ahead and scroll down to the next part here. Now this one here says finding a vector's magnitude and direction. Okay, so go ahead and take a look at this here and see what it says. What this is telling us to do now is convert a vector component form into magnitude and angle form. So here we have the x component and we have the y component. All right, so let's go back over to here. So if you were to write this out, we would have here, let's say it's still vector A. So here's the x component. The x component is going to be 5, let's say. We'll put 5 here. And let's say the y component, man, the y component is going to be, let's say, 7 here. Okay, so there's our x and y component. Here's the x component, here's the y component. So to find the magnitude, okay, so let's see what this actually is. Okay, so here's our coordinate, here's our Cartesian coordinate. So x is 5, so we'll say 1, 2, 3, 4, 5. So it goes about right here. And 7 up, we go up 7. So here's 1, 2, 3, 4, 5, 6, 7. So it's kind of like here, and here's the vector is kind of like that. All right. So here's the x component here, or the x component. And this up here is the y component. Man, I got to get a stylus. Y component right here. Okay, so what we do here, so this is like the Pythagorean theorem. What's the hypotenuse? The hypotenuse is going to be the magnitude. So the magnitude of A, okay, we'll go ahead and kind of go like this here, very carefully write it in here. Okay, the magnitude of vector A is going to be the square root, right, of, let's say here, 5 squared, that's the x component, 5 squared plus, and this is going to be 7 squared, like so. All right, so we'll go here, and we'll use our calculator over here. Let me clear this up over here. So let's go ahead and do the square root, which is right here. I'm going to add a parenthesis, and we're going to go 5 squared, right? 5 squared, close parenthesis, plus parenthesis. We're going to go 7 squared, put 2 there. Let's go 7 squared, like so. Close parenthesis, and close parenthesis, and then go ahead and see what this gives us. This gives us 8.6. So the magnitude of this vector is 8.6. We'll put it right here, 8.6, like so. Now to find the angle theta, okay, so normally here, this is, here's the angle theta, and we have a y over x, that's going to be the tangent. So to find the angle, we have to do what's called the inverse tangent or the arctangent. Okay, so this is going to be tangent, the inverse tangent, so I'm going to say tangent minus 1 here. And the y component is going to be, let's say, 7. Okay, and the x component here is going to be 5. Okay, and let's see what that is. Okay, so over here on a calculator, we'll clear this out. We have to go the inverse or second function, and we want to do the tangent. So arctangent is what we got, and it's going to be 7 divided by 5, close parenthesis, equals. It gives us 54.4 degrees. So here is 54.4 degrees. Now, take a look at this. Before I even did this, I knew because of the x and y components, I was going to be in quadrant number 1. So 54 degrees looks like it's in quadrant number 1. Now to check our answer over here, I'm going to go ahead now. Let me clear this out here. let's clear this out. So I'm going to put the components in here. So the x component was 5, and the y component here was 7. And so here it is, and looks like here's the magnitude, 8.6, and the angle is 54.4, so it looks like we're doing pretty good. So I'm going to save problems 10, 11, and 12 for at the end of this video for you to practice on. All right, and moving along right here, now we want to add vectors together, So let's go back to our simulation here, and let's go ahead and get rid of, let's go back to, so here's vector A. So here's vector A, and we're going to put it right here, and let's bring out vector B, okay? And let's put vector B, let's make it a different orientation. Let's make it like that. There's vector B. So suppose somebody told us that they wanted to do, we'll call it vector C as a new vector. Vector C here is going to be vector A, right? Here's vector A plus vector B. All right, plus vector B. So vector A plus vector B. So we're adding, and so what this tells us is we have to do vector A and add vector B. So this is called the head to tail method. So what's best to do this is take vector A and go ahead and put it down right here. So there's, put it at the origin. So here's the tail and here's the head. So this is called the head to tail method. We're going to drag vector B over here, and we're going to put the head of vector A to the tail of vector B, like so, like right there. And now what we need to do is called the resultant. Here that's called the sum. This is the resultant vector. We're going to put it right here and see how it matches up. Boom. So so add these two vectors together. That's where we end up, and this is now the resultant vector, vector C. Okay. Now, what happens if we were? Could we also do vector? Could we do vector B first, like this? Vector B plus vector A. Can we do that? Well, let's find out. Okay. So let's get rid of the sum. Okay. Let's go ahead and move this vector over here, and let's move this over here. So let's start with vector B this time. Vector B is going to be right there, and here is going to be vector A. Head to tail method, like so. Let's do the resultant, which is right there, and look what we got here. Right there, the origin, and let's kind of put this, let's get rid of this sum here. Let's get rid of that. And let me put this to the head to tail, like right there. Now let's do the sum. There we go. There's the sum. So yeah, you get the same result. So A plus B equals B plus A. So vector addition is commutative. Okay, is commutative. All right. So let's take a look here, and here's some more theory and an actual number crunching, actually calculating it out here. Let's go ahead and do an actual example here. Let's see what we got here. Okay, so this says add a vector whose magnitude is 13 and angle is 27 to one whose magnitude is 11 and angle is 45. So I'm not sure if I can do that over here. So let's see if we can maybe make that over here. So let's go ahead and move this out of the way. Let's take vector A here, and it says magnitude is 13. So let's see if I can make it 13. Okay, there's about 13, and the angle is going to be angle is 27 degrees. So here's 27 degrees, and might be kind of tough to do. Angle 13. Well, yeah, it's kind of hard to do here. So let's go ahead and kind of see how we can do it old school way. So here is a vector whose magnitude is 13 and angle is 27. All right, so what we want to do here is we want to break this vector. Maybe we'll call it vector A. So vector A here, uh, the magnitude of vector A here is going to be, let's say it's 13, right? It's 13. And the angle here is going to be, what is it? 27 degrees. So it's going to put 27 here, like so. Okay. Vector B is right here. So here's vector B. And we'll say that vector B is going to be magnitude is 11, right? And this angle theta is going to be 45 degrees. All right, so in order to do this old school way without a calculator or by hand is to go ahead and break these into components, vector A and B into components. So here is, here is AX, Right? Here's AX. Okay. And let me go ahead and do the calculator over here. Let's do clear. So AX is going to be, remember, it's going to be 13 cosine of 27. So we're going to go ahead and put down here 13 cosine of 27, which is right here, and close parenthesis, and we'll see what that is. It's 11.6. So the x component is going to be 11.6, like so. Okay, and the y component here, let's do the y component here, a vector A here, it's going to be 13 sine of 27. So 13 sine of 27. And let's see what that's going to give us 5.9. So we'll make this here 5.9, like so, 5.9. There we go. All right, so now let's do the b. So bx here. So here's the x component of b. We'll go here. So the x component here is going to be, let's see, 11 cosine 45. So 11 cosine 45 degrees. Now, let's see, let's go back a little bit. 45, okay, close parenthesis, and let's see what this equals. It equals 7.8. So this is going to be 7 here, 0.8, okay? And now 45 degrees, we know it should be the same answer because sine and cosine are the same for 45 degrees, but let's go ahead and just do it anyways. So here is by, okay, the y component here, and let's see what we got. We'll go ahead and do 11 here, but this time sine of 45 degrees. We'll go here, and that gets us 7.8 again. So remember, sine and cosine are the same at about 45 degrees, okay? 7.8. All right, so now, so here's vector A, here's vector B. So we have to add the x components together and add the y components together. So we'll say that C, vector C is the resultant. Cx is going to be, it's going to be 11.6 plus 7.8. So 11.6 plus 7.8. 7.8 gives us, let's see, I must have messed up there. So let's do this again. 11.6 plus 7.8. 7.8, and that's going to equal 89. Whoa, is this plus here? Let's see what we got going on here. Let's see, wait a minute. So 11, so let's clear this out. Clear. Let's do all clear here. And let's see what we got. Let's do 11.6 plus, right? 7.8. 7.8. And let's see what that equals there. Good, 19.4. Boy, I'm not sure what happened there. So here is 19.4, okay? And the y component here, the y component is going to be, the y component is going to be, was it 5.9? 5.9 plus, looks like 7.8, 7.8. And that equals 13.7. 13.7. All right, so now we have the x and y components of the resultant vector. So now we have to do the Pythagorean theorem and also do the inverse tangent. So let's go ahead and do that real quick here. So the magnitude of vector c here is going to have to be using, it's going to have to be the Pythagorean theorem. So we'll do it over here so you can see it. We'll go here, and it's going to be a parenthesis. It's going to be 19.4 squared, right? And close print. Oh man, hold on. So 19.4, okay, 19.4, and we want to square that. Close parenthesis, and I want to add to it 13.7 squared. So we'll do parenthesis 13.7 squared. Close parenthesis and close it up. And that gets us 23.7. So the magnitude of this new vector is 23.7. So 23.7, like so, okay? And the theta, the inverse, is going to be inverse tangent, right? The inverse tangent. So we'll go over here, we'll do inverse tangent, and it's the y component over the x component. So the y component here is 13.7, 13.7, man, 13.7 divided by, looks like 19.4, 19.4, close parenthesis. And that gets us an angle at about 35.2 degrees. So we'll say here 35.2. So we should learn how to do this by hand. So let's do this again using the vector calculator, which is much easier. So vector calculator. So here we have two vectors. We're going to add 13. So magnitude of vector A was 13, and the angle it was 27 degrees, okay? And here's the x and y components. Vector B was a magnitude of 11, and the angle was 45 degrees. So here's 45 degrees. All right, so when we add it up here, we can see the result vector is 23.7, 23.7. Theta is 35.2, 35.2. Here are the x and y components, they match up. So I would, you can go ahead and use a calculator here to speed things up, but we should be familiar with how to do this by hand. All right, so this will kind of conclude, and we'll save 14, 15, and 16 for at the end of the video questions. So this will conclude the videos here as far as the presentation. The next part here will be the problems for you to work on. All right, any questions, please let me know. You guys take care.